5.5 continued, logarithmic equations. So a logarithmic equation is one in which a log of the variable is occurring. So I'm taking log of x or whatever my variable is. So what we're going to work with here is switching it first into exponential form. Well, first getting log by itself, but it is, and then getting this in exponential form. So remember, this is my base, this is my exponent. So that's 2 to the 5th power is equal to x plus 2. And now it's a lot easier to solve for x. I'll subtract 2 from both sides. Well, actually, 2 to the 5th is what? 32. And then we can subtract, so we're going to get x is equal to 30. So first you're going to isolate the log, and then you're going to write it in exponential form, and then solve like any algebraic equation. All right, so same kind of concept here. I want to get the ln to, I really want to get rid of that ln, right? So I can write this in exponential form. Just remember this means log base e. Okay, it might be easier to switch that first. So that's e to the 8th power is equal to x. And then we just have to rely on the calculator for this because we cannot do that on our own. So we can go in and hit, let's see, second ln gives us e, and that ended up being to the 8th power. So about 2,980.96, I guess. Okay. So x is about 2,980.96-ish. All right, for the next part, same kind of concept here. So I'm going to rewrite this. That's 2 to the 3rd power is equal to 25 minus x. And then we just want to solve for x here. So that's 8 equals 25 minus x. I'm going to subtract 25 from both sides. So I'm going to get negative 17 equals negative x, or x equals 17. One thing, though, with these problems, you do want to just double check is, does this actually fit the domain? So here, no problem. I can take the natural log of that horrible number. That's not going to be an issue. Here with the 17, 25 minus 17, that's going to be a positive number. No problem. I can take log of that. Just remember the domain is that whatever I'm taking the log of has to be greater than 0. Okay, so whatever I'm taking log of has to be greater than 0. All right, so for this one, we want to get the word log by itself. So really, I want to get this all by itself first and then solve the problem. So I'm going to subtract off that 4. And that's going to give me 12. I'll divide by the 3. So now I have log of 2x is equal to 4. Much better. Don't forget there's a hidden little 10 in there, so that might help us out a little bit as well. We have 10 to the 4th power is equal to 2x. 10 to the 4th just means 4 zeros. 1, 2, 3, 4. And then we have 2x. So we're just going to divide, and that's going to give us 5,000. Again, just want to double check that won't be a problem. But 2 times 5,000, that's definitely greater than 0. So I can take the log of it. All right, let's take a look at this next one. So we do want to combine if we can. We do have the same base here. So if we have logs that are separated out, we do want to put them together. So that, remember, is going to be multiplying what we're taking the log of. So we have log of, that's x plus 2 times x minus 1. You could FOIL, but it might not be worth it. So let's kind of hold off for a minute here. And let's rewrite this. So don't forget a hidden 10. So that's 10 to the 1st power is equal to x plus 2 times x minus 1, and it's looking like, yes, we're going to need to FOIL that out. All right, so that's 10 is equal to x squared minus x plus 2x, so plus 1x minus 2. And let's make this say equals 0. So we'll subtract the 10. So 0 equals x squared plus x minus 12. Now we can factor in zero product property. So we're going to have x and x, a plus and a minus. Let's see, 4 and negative 3 looks like it's going to do it. So zero product property, we're going to get negative 4, and we're going to get positive 3. We do want to double check that on those domains, though. So if I were to plug in a negative 4 here and here, that's going to give me logs of negative numbers. That's no good. That can't be our answer. It doesn't fit the domain. However, if we put in 3, that's 5 and 2. I can take log of that. So x equals 3 is my answer, but negative 4 gives us that domain error. Okay. All right. We could also do this algebraically. We could do a few different things. We could look for the intersection like we did on the last video and say that we have y equals log of x plus 2 plus log of x minus 1 and y equals 1 and just find the intersection. And that would be perfectly fine. Or we could make this say equal 0 and then just find the intercepts, which would be the same concept here. So real quick, let's take a look at what that is. We have y is equal to log of x plus 2 plus log of, we said, x minus 1. And then the next one we have 1, and we just want to find that intersection point. So we're going to hit second, trace, we're going to intersect, so choose 5. And then we just want to make sure that we have the right parts here, so something in there. And it looks like we're going to get 3, 1, which makes perfect sense here. 3 is that answer that we were looking for. Okay. All right, so let's take a look at the next one. So this one we do want to do graphically. We have x squared equals 2 natural log of x plus 2. So it may be easier. You could absolutely find the intersection here, but because this is a parabola and a natural log, making it say equal 0 might be easier. So let's see. I could just move this stuff over and we'll have y equals, well, really, not y equals yet. We have x squared minus 2 ln x plus 2 is equal to 0. So we can say that y equals this and then find the x-intercepts. Okay. So let's see. X squared minus 2 ln x squared minus 2 natural log of x plus 2. And we want to find the intercepts. Okay. So let's see. Second trace intercepts are zeros on here. All right. I don't know where my cursor is, but we want to make sure we go to the left, to the right, and take a guess. Oh, it might not make me take a guess. Oh, let's see. To the left, to the right. Your TI-84 will make you guess, but it looks like negative 0.7 is one of them. And let's do the other guy. So to the left, to the right, and it looks like 1.6. So negative 0.7, I guess is about negative 0.7 and 1.6. Okay. All right. So sometimes we can have some word problems with these as well, but it's basically using the same kind of rules. So here we have I sub O and I, and these are the intensity of light before and after going through some material. X is going to be the distance in feet that light is traveling through a material, whether it's a prism or a window or whatever. So here K is representing a constant in this formula, and that's just depending on what the material is. So thicker materials or different kinds of materials are going to change that intensity, like, you know, if there's tint or not or something like that. So first we want to solve for I. Regular I we want to get by itself. So let's start with that. We have negative 1 over K, natural log of I over I sub O. Is equal to x. So we want to start to isolate that I. Let's move that negative 1 over k to the other side. I can multiply by negative k on both sides. Okay. So we have the natural log of I over I sub O, and that's equal to negative kx. And then let's rewrite this. Remember, that's really log of e. So we have e to the negative kx is equal to I over I sub O, and we'll just multiply by I sub O. So I is equal to I sub O times e to the negative kx. All right, so we have our equation. Next thing we want to do is if k is equal to 0.025 and the starting light intensity is 14, find the intensity for a 20-foot depth. Okay, so we're just plugging in here. So we want to find I. If I sub O is 14, e to the negative k is 0.025, and x we said was the distance, which is 20. So really this is just relying on our calculator here. All right, so we have, second quit. We need 14 times e to the negative 0.025 times 20. And that's about 8.5.